charge. So what do you really need to know about electrostatics? There are 4 basic concepts that we're going to cover before we move on to circuits. First, the effects of static electricity are explained by a physical quantity, charge. There are only 2 types of charge, which you should have learned about in chemistry, if not before that, positive and negative. Again, as you've probably also learned, like charges repel and opposites attract. And here's where we get to the physics side of it. The force between charges decreases with distance. Conversely, it also increases as you get closer. Alright, charge is a property of matter, just like mass, okay? Matter is made of atoms. Electric charge is a property of those particles that make up every atom. That means on a fundamental level, just like mass, electric charge is a basic property of matter. Mass can only be 0 or a positive number. Turns out even antimatter has positive mass. Electric charge, on the other hand, can be positive, negative, or 0. You probably learned in chemistry that neutrons have 0 electric charge. Speaking of those particles, here's the structure of an atom. This should look familiar. You have a nucleus made of protons and neutrons in the middle, and you have electrons making up the electron cloud around that. So a complete atom has equal number of protons and electrons. Therefore, as a whole, it has 0 net electric charge. As you learned in chemistry, any atom that is missing an electron or has an extra electron is actually an ion. This brings us to the elementary charge, which is the magnitude of the charge of a single electron or a single proton. The value is 1.602 times 10 to the negative 19th. See? Hold on, we'll get there. It can also just be written as a lowercase e, not to be confused with the fundamental constant 2.7 whatever. Okay, so I can write the charge of an electron as negative 1 e. It has negative 1 times the elementary charge. Alright, here's that C thing. It means coulombs. It's the fundamental SI unit of electric charge. It's notated as a capital C, as we saw in the previous 2 slides. And it's named in honor of Charles Augustin de Coulomb, a French physicist who made the first accurate measurements of electric force. 1 coulomb is a lot of charge. To put it in perspective, it's 6 times 10 to the 18th electrons. Ordinary static electricity, like when you shuffle your feet on the carpet and shock yourself on the door handle, is less than 1/millionth of a coulomb, or a microcoulomb. A lightning bolt is approximately 10 coulombs of charge, and I wouldn't want to get struck by that.